Maya, today we've got a research paper with the best name in AI all week. It's called Reroute, Don't Remove.
Sounds like marriage advice, Marcus. But it's actually about making vision models faster, and I love it.
Right. So, before we untangle that, here's the question of the day. How do you make an AI that sees without it costing a fortune to run?
And the answer in this new arXiv paper is genuinely clever. Let's get into it.
Okay, the setup. When you hand an image to a vision language model, it doesn't see a picture. It chops that image into hundreds, sometimes thousands, of what they call visual tokens.
And every one of those tokens costs you. More attention computation, more memory in the cache. So images are expensive to process.
So the obvious fix everyone's been using is rank and remove. Score the tokens, keep the important ones, throw the rest out.
Which sounds smart until you realize you might be deleting the one detail the question was actually about. That's the catch with throwing tokens away. You can't get them back.
And that's the whole insight in the title. The paper says, don't remove the tokens, reroute them, make it recoverable instead of permanent.
So instead of deleting half the image and hoping you kept the right half, the model can still reach the stuff it set aside if it turns out to matter. That's a smarter trade-off.
Now the honest caveat, this is a fresh arXiv preprint. The full results aren't peer-reviewed yet, and the abstract we have cuts off before the hard numbers. So, promising idea? Watch for the benchmarks.
Fair, but the reason a non-researcher should care, Marcus, cheaper image processing, is what gets you AI on your phone that can actually look at a photo without melting the battery.
Speaking of clever engineering, there's a second paper today that rhymes with this one. It's about Mixture-of-Experts routers.
Okay, translate that one for me, because Manifold Power Iteration is not a phrase I use at brunch.
Fair enough. A Mixture-of-Experts model is like a big team of specialists. The router is the receptionist deciding which expert handles your question. Get the routing wrong, you waste the whole model.
And this paper redesigns that receptionist, so it picks the right expert more accurately. Same theme as the first story. Better routing instead of brute force.
Which is the quiet trend underneath both papers. The frontier isn't always a bigger model. Sometimes it's just being smarter about what the model already has.
And our last item proves research isn't just abstract. There's a paper on robot arms learning to feel force without expensive force sensors.
Right, it's called FACTR 2. The method next estimates the external torques on a robot joint from data alone. No dedicated sensor needed.
And that matters because force sensors are pricey, which is why most cheap robot arms are clumsy with delicate tasks. Give a commodity arm a sense of touch and software, and suddenly,